So let's just finish this one off really quickly. The graph now is given by this expression, and it's actually got two variables now that we need to find. But we're given a bit more info. We're given that there's a stationary point at this coordinate rather than just a particular x value. And how that's going to let us access this question is, if you think about it, okay, well, now that you have an x and y value, what that means is you can go back to this expression and say, okay, well, where are the x and y values? The x and y values are the x values, and well, f of x is your y value essentially, right? So that's going to be able to be substituted in. So we know that we've got 2 equals to 2 cubed plus, 2 squared a plus 2b. And we can simplify this out a bit. That's going to be 8 plus 4a plus 2b. And then we can say, gather some like terms here. Okay, so that's not too helpful right now. But as you know, if you have two variables, we need two equations, a simultaneous equation. Right? So we need to use this piece of information. It has a stationary point at a, 2, 2. Right, so we need to, I don't know why I find that funny. Okay, cool. Like, so a stationary point here, we need to take the derivative of. So now, keep in mind, you can take the derivatives even though you've got a's and b's there. Remember, they're just constants, so they're just going to stay there for now, right? So it's f dash of x is equal to 3x squared plus 2ax plus b, right? Because b is just constant value, so that's the thing that will remain. We've got x there. And now this point is a stationary point at 2, 2. So similar to that previous one, we can say that at f dash of x equals to 0, well actually say, I should phrase it as at x equals to 2, f dash of x is equal to 0. Right, and so I've got 0 is equal to, now I can substitute those in, so 3 times 2 squared plus 2 times 2a plus b. And that's going to be, what's that, 12 plus 4a plus b. And now at this point here, depending on kind of what method of simultaneous you like to do best, you can either use substitution, so you could put b as the subject here and then substitute back into this. Or if you're comfortable with elimination as well, that may be easier. So for example, if I've got 12 is equal to 4a plus b, sorry, negative 12 is equal to 4a plus b, I've got two equations here, 1 and 2. So I'm going to eliminate them, and what I'm going to do, I'll just write over here. Let's go 1 take away 2, the best way to do it. I'll do 1 minus 2 here, so I'm going to get negative 6 take away negative 12, so that's going to be 6. 4 a's will go away, that's fine. And 2b take away b, so b is just equal to 6. That's nice. All right. And then now that we've got b, I can substitute any one of the others. They're both like equally the same, to be honest. Let's go sub b equals to 6 into 2, so I don't have to worry about coefficients that way. So negative 12 equals to 4a plus 6. And then we've got negative 18 equals to 4a. A will equal to negative 18 on 4, or that's negative 9 on 2. Okay. So we should just check these equations, make sure they all work. Cool. 4 times negative 4.5 plus 6. Yep, and they do work. Perfect. Okay, so that's how you can sort of create a simultaneous equation out of the information that you're given here. You need to make sure you're utilizing every piece and putting them together in order to solve this problem.